Okay, the findings, just like with a lab report, the important thing here is to keep what they report, the statistics and the changes in the measurements, separate from the implications. That comes next. That's the largest section. But now we're just going to report what they found. So, okay, overall there was a similar number of thefts on campus before and after the placement of the signs. Okay, this has made me realise that I have missed something out of the method, because they did measure before and after, didn't they? Here's the graph. Yeah, the 12 months before and the number of notified bicycle thefts before and after the intervention of the experimental control. So I missed something out of the design. Okay, what? Let's go back up. The researchers placed large signs above cycle racks. Campus security monitored cycle thefts for the year before the signs were placed and for the year after in these locations and in a number of control locations also around campus. Okay, overall there's a similar number of thefts on campus before and after the placement of the signs. I think it was 68 in the experimental locations. Let's just show that I understand that experimental means they've got the signs. Experimental locations with signs, thefts reduced by 39 to 15, and then in the other locations 31 to 51, 39 to 15, 51, right? Okay. So in the experimental locations with signs, theft reduced by 39 to 15. In the control locations without signs, thefts reduced, increased by, no, I've written that wrong, increased from 31 to 51. Okay, I'm just going to point out what I'm doing here. So these two sentences here, which I can't highlight properly, are identical in structure. They both say the experimental locations, the control locations. They both say then with signs, without signs. And then they say thefts reduced or thefts increased, and then the pairs of numbers. So when you're giving information that you want the reader to compare, you should give it in the same format. It's not exciting or interesting to vary how you present it. Just repeat the same sentence structure, making the relevant changes. And spell locations right. In the experimental. Okay, so that's the headline result. I can even give these as percentages. Let's reduce, let's say, down 60 something %. Okay, what I'm going to do there is I'm going to put the letters TK. What I do is when I'm writing and I don't want to have to look up a detail, I put TK in because it reminds me to, when I read back through, to go and look up anything where TK is written. The reason you use TK is you never use the letters TK in any English word, and so if you do control find, then control F, sorry, if you do a find on your text, you'll be able to find it. But the percentages were 60, up 62 and down 65 or something like that. I'll look them up later. So that's the headline result. Another paragraph. They also looked over time. No, they did this odds ratio thing. Okay. odds ratio was calculated following the method. They followed someone else's recommendation. The method of, I'll look that up later, which compared the ratio of change in the control location to the ratio of change in the experimental location. Always define any abbreviation before you use it again. The odds ratio was 4.28, 95% confidence interval. Okay, so the fact that this was different from 1 would be the odds stay the same. The odds ratio being well above 1 means that there was a big change, and you can see that from the graph. That if you wanted your bike not to be nicked, you should have left it in the experimental condition after the sign. Okay, an odds ratio was calculated. The odds ratio was 4.28. The odds ratio was also computed. I'm going to say calculated because I said calculated already. There's no need to use different words. It's just confusing for the reader. The odds ratio was also calculated for the first and second halves of the year. This is somewhere in here. Okay. So that's the first half. So, am I going to tell the reader the numbers? The odds ratio was calculated for the first and second halves of the year. It was in both halves. It was significantly above 1. So the first half, it was 4, and the lower bound on the confidence interval was 2.28. Second half it was 6.68. The lower bound on the confidence interval was 3. So that's definitely true. They say there is no evidence of any attenuation of the effect. So what they say is that there's no evidence that these two odds ratios are different. But they don't test that. Directly, do they? They just say that they're both significantly above 1. Yeah, okay. So that's a bit of a grey area. So they're definitely both significantly above 1. And the confidence intervals overlap a lot. But still, the second half... Yeah. Oh yes, the second half odds ratio is greater, so the effect is greater in the second half, so it's definitely not that it's diminishing, but there's less evidence of it over time. Okay. So here's me having a little thought when I should be writing. The odds ratio was calculated for the second halves of the year. In both halves it was significantly above 1. Okay, I'm not going to give the stats. That's in the paper. You don't need to do that. Okay, let's just check how I got everything. Describe the results, focus on the important comparisons, mention a difference which is statistically significant, mention which differences or lack of differences are important, mention the size, importance of differences. Was the statistical analysis appropriate? Okay, so this is the experiments here. is very simple. It's a pretty much one comparison. Well, there's the before-after comparison, and then there's the experimental control condition comparison. It's worth mentioning the odds ratio methods followed incorporates the influence of displacement from the experimental displacement of what? Displacement of thefts from the experimental locations to the control locations. Therefore, it is theoretically possible, as occurred here, for an intervention which does not reduce crime to have a highly significant odds ratio. Okay, could they have done a different statistical test? Could have done an ANOVA, and presumably that would have shown, and they would have been looking for a significance. No, they couldn't have done an ANOVA because these are natural frequencies. If this was data which, you had 100 participants each contributing a score, you'd have some variability around these numbers here, and then you could get an interaction term. But they're just counting a single number. There's no variability, because they just count and they say 39 bikes were stolen, and they want to know, is there a significant difference between these two? Well, they did do a statistical test, didn't they? Was it Fisher's exact? Okay. Yeah. Okay. So they do a test. Fisher's exact test. Significant interaction between presence of the sign and time from the graph. It is clear that the sign reduces. It's clear that it appears to reduce thefts in locations. The signs appear to reduce. Clear. Okay. I'm going to change the sentence around. From the graph, it is clear that locations with signs show a reduction in thefts. Locations without signs show an increase in thefts. Okay, I'm going to change this again because I want to emphasize both the signs and the time factors, which are the two things in this room. From the graph, it is clear that the introduction of the signs reduces thefts at those locations, whilst at other locations thefts increase. That just describes in words what I've already shown with the numbers here. So it's a little bit repetitious. Okay.